Hello, my fellow mathematicians. Welcome to the study of exact differential equation. Here we are given function of xy plus y squared plus y, everything dx plus bracket x squared plus 3x y plus 2x, you close bracket, dy is equal to 0. So the first thing, it is to check whether the given equation is exact or not. So the function where dx is, we define it as function m. In our case, it is xy, which is equal to xy plus y squared plus y. Then we get partial of m with respect to y. So you have x, after differentiating this, plus 2y plus 1. Then the other part where dy is m, which is a function of x and y. In our case, it is x squared plus 3xy plus 2x. Then we get partial of n with respect to x. So when we differentiate this, we are going to get 2x plus, we differentiate here 3xy, we are going to be left with 3y. When we differentiate 2x with respect to x, we will be left with 2. Then you compare whether partial of dm with respect to y is equal to dn with respect to x. In our case here, as you can see, this is x plus 2y plus 1. It is not equal to 2x plus 3y plus 2, meaning that our equation, our given O.D.E is not exact. Then we are going to employ the rule which tells us that if you have 1 over m multiplied by partial of n with respect to x minus bracket, that's, so we substitute, our partial of n is 2x plus 3y plus 2. Our partial of, that is our partial of n. Our partial of m, here, our partial of m is x minus 2y minus 1. So you simplify. So you have 2x minus x, which will give you x. You have 3y minus 2y, which will give you plus y. Then you have 2 minus 1, which will give you plus 1. This one will give you 1 over y. So once you make use of that rule, the next thing that you do now, you get what is called the integration factor. So our integration factor will be given by exponential integral of function of y dy, which is equal to exponential integral 1 over y dy, which is equal to exponential natural logarithm of y after integrating 1 over y dy, will give you a natural logarithm of y. This is equal to y. That is equal to y. Once now you obtain the integration factor, you multiply your given O.D.E with the integration factor. When you multiply, we are going to obtain the following. We shall obtain x y squared plus y cubic plus y squared. This is our dx plus bracket x squared y plus 3xy squared plus 2xy dy is equal to 0. That is the result we obtain after multiplying our given O.D.E with the integration factor. Once now we have our new O.D.E, the next thing is to check it and see whether it has become exact. So our m, which is a function of x and y, is equal to x y squared plus y cubic plus y squared. Then you get partial of m with respect to y. In our case, it will give us 2xy plus 3y squared plus 2y. Then you get the function of n, which is a function of x and y, which is equal to this part here. And in our case, it is, we have x squared y plus 3xy squared plus 2xy. Then we get partial of n with respect to x, which will give us 2xy plus, we differentiate this, 3y squared plus 2y. Once you get that, you compare your partial of m with respect to y, you see whether it is equal to passive of n with respect to x. In our case, it is equal to 2xy plus 3y squared plus 2y. So since passive of m with respect to y is equal to passive of n with respect to x, that tells you that our equation is exact, meaning that our solution will be of the form this one. So our total differentiation is of this form of this equation plus passive of f with respect to y dy is equal to 0. Now comparing this with what we are given, it means that passive of f with respect to x is equal to xy squared plus y cubic plus y squared. So after comparing, and also our passive of f with respect to y is equal to x squared y plus 3x squared y plus 2x plus 2xy. So now, from this one, you can call this equation A, and this other one, you call it equation B. We are going to integrate equation A. So from equation A, we can multiply both signs by dx to be left with df. Equation is of this form: integral of passive of f, which is equal to bracket x y squared plus y cubic plus y squared dx. So you integrate these equations both sides. So when you integrate the left hand side, you will get a function of f of x, which is equal to you integrate this one term wise. So when you integrate x, we will get x squared over 2 y squared plus, here you will have x y cubic plus x y squared plus a function of y. So that is what you obtain after integrating that function. Then you differentiate f of passive of f with respect to y to obtain the following. So here we are going to obtain x squared y plus 3x y squared plus 2xy plus g of that. Then we compare this equation with what we were given to obtain the following. So from our O.D.E, or from what you have called B above, we have df of y, which is equal to x squared y plus 3xy squared plus 2xy. So you can call this equation Roman 1 and this other one equation Roman 2. Now when you compare equation Roman 1 and equation Roman 2, the left hand side is equal. So that tells you that you can equate the right hand side. So equating the right hand side of equation 1 and 2, we are going to obtain x squared y plus 3x y squared plus 2xy plus g prime of y is equal to x squared y x plus 3x y squared plus 2xy. Then you can see x squared y is on both right side and the left side, so you can cancel them. 3xy squared is also on the right hand side and on the left hand side. Also 2xy is on the right hand side and on the left hand side, you can cancel them. So that now on the left hand side you will be left with g prime of y, is on the right hand side we are left with 0. Then from there you integrate this equation both sides. When you integrate and differentiate, you get that function. So g of y is equal to constant c. When you integrate 0, you get constant c. So substituting the value of function of g in the equation above, we are going to obtain our result as f of xy is equal to x squared of y squared divided by 2 plus x y cubic plus x y squared plus constant c. If you want, you can check whether your working is correct. So we check by getting partial. You get partial of f with respect to x. In our case, we are going to get x y squared plus y cubic plus y squared. Then you get also partial of f with respect to partial of y, which will give us, in this case, x squared y plus 3xy squared plus 2xy. Then remember the fact that our equation is of this form, plus is equal to 0. Now when you take these ones with what you are solving, you are going to find out that our working is correct. So that is the result for our question which we were given. So thanks so much for taking time to study with me on the 9 difference equation, which is exact. For further studies of such equation, I request you to tune in my YouTube channel so that we may continue learning together. Remember to subscribe to the channel if you have not yet subscribed, so that you don't miss a single video which I upload for us every day. Bye bye. See you in the next video as we continue learning together.